we have there's two distance. Over here, when you talk about the first one, it's only x1 distance, one side is grounded. Okay? But when you talk about these two components, there's x1 and there's x2. So there's a difference between x. Okay? So you can put it x1 minus x2. Then damper is nothing but the damping coefficient is nothing but b, and x dot. So dot is the capital letter D, x1, x2. So I just write down here for understanding. So you can write this one. Okay, x1 dot. Okay, so instead of dot, I put it like capital letter D. So I can write directly x1 minus x2. Because I don't practice this way. So straight away, any one dot or two dot, I can put accordingly D or D square. Okay, questions? Are we good? Okay, so basically now we are in the damping coefficient B, D x1 minus x2. And the next one is second mass. Okay, then better put the relevant M things so that it will be not mixed up. So M2, D square x2, right? Yes, because it is just like the formulas is coming over here. Sorry. And the last one, there's the last spring over here, K3. Spring is nothing but just delta x, which is nothing but x2. So are we good on this? All the 6 component equation. Okay, I'll repeat. Over here, the first spring, so K1 and delta x is nothing but just x1. Okay, that is your first component over here. And maybe we first I go through the springs easier. Okay, so the first spring is K1 x1. Okay, so that's the first one I can say. And there's a second spring K2. Yes, there's a second spring K2 delta x. Okay, so x1 minus x2. And third spring over here, spring constant K3 delta x. The other side is grounded. That becomes your So springs is all delta x. Okay, so 3 spring I added. Now talk about mass. There's 2 mass. Mass 1, mass 2, and this correct because as per the equation is nothing but acceleration. Force and mass into acceleration. So that becomes like this. Or you can write this way: m1 x1 double dot. Okay, so I don't prefer this way. So you can put it. If you say double dot, put this one. Okay. So maybe I delete this one first. So that is your mass first equation, then another mass here. Questions on the mass? Okay, then next is damper. Okay, damper is B is the velocity, so that's one B is there because x dot on it, delta x dot. So x1 minus x2, that's your fourth equation. Okay, so this is all component equations. Okay, so it's very simple. Any question given, try to number it so that you know you won't miss out. Like a component 1, 2, 3, 4, 5, 6. So 6 component, 6 equation as per the component. Then question at this moment on component equations. Of course, when you ask me, I written both way. Like what we see, a traditional differential equation method, this one. Then same way, if you want to write in Laplace method, you can see this one, the last one. Okay, as long as you see S squared, that's the Laplace method. Okay, so actually I've tried to put everything in one version. Okay, but it's your choice. Either you can go on the board where it's say called differential equation, or this one with the S is called Laplace method. Instead of D, capital letter D, we put S. So I say S squared, where I can put it like D squared. Okay, that's the only difference on it. But anyway, just display over here. You don't need to follow exactly here as a both decide one method, any one method. Okay, so we have a 6 equation based on 6 component over here on this system. Then after the component equation is force equation. That's all. The equation is completed. So questions on 6 equations? Anything? Yes.
Can you explain 7 and 8?
Yeah, the next one I'm going to come is a force equation. Where the 6th equation is more on component basis. The next two is a force equation. Okay. Now 6th equation, if no question, I can proceed with nothing but force. This is, I can say, all the components. Now we talk about force. The force is very simple in a way like we know our input is nothing but U. Okay, you better full picture. As for the question, it say like U is the force input, X2 is the displacement, also called the output. Is in the translation must read the question, then only we know which is input, which is output. Otherwise we cannot know it. The other way, of course, they will indicate by the arrow mark and things. Okay, but of course the arrow mark will say so here. When I'm trying to push this one, this spring and mass will be resist, and the next one is a damper, and then the second mass, and there's another spring. Okay. So what is the force? Of course, input force is U. So when you say there is external force I'm applying, what is resisting on it?
V1.
Yes. So we have maybe I put it like over there is force of spring K1, right? First is resist by K1. Yes. Then we have mass and K2 and B. So all is going to be resist on it. By applying a force, say if I'm applying here, this is going to stretch, this is going to be compressed, this is going to push. So these 4 components is equivalent to the applied force. So are we good? So basically I can say K1, mass 1, K2, and we have a damper. Are we good? When I'm applying the force, these 4 components straight is act on it. When I apply over here, the force, this, the 4 component resisting the applied force. In another terms, okay. The force when I apply, which are the component is stopping me. Okay, so this 4 component will be stopping the input force as per this setup. That's your 7th one. So we good? Okay, so last equation. So at the end of the day, the system should be equilibrium. Okay, now we now see these 2 components, which is equilibrium with these 2, right? Because when I apply this one, this is trying to resist. So this is equilibrium to this, right? So I can say one more force, which is K2B is equivalent to the mass 2 plus we have a damper, we have a spring. Can I write this way? We have spring 2 and damper is nothing but these 2 components is opposite to these 2. Okay, spring 2. That's 6. So we have mass and spin constant trait. So that's makes the entire system stable on it. Are we good? Or we have any question on 8th, 7th and 8th? So that's why written here, yes, M, K, K2B, everything is there, which is based on the input force, whereas applied force, equilibrium, these 4 components attract each other. Yes, questions?
Number 8, can you repeat?
Okay, number 8. Okay, so now this is going to be a force. Now you get some motion on these 2, right? So, and the system is going to be equilibrium, which is stopped by these 2 components. So the mass and this spring will oppose whatever force getting over here. And that is, this two force is equal to whatever the nearest component over here. Okay, nearest component, these two components, which is equilibrium trying to resist on it. That's the 8th equation. Are we good on 8?
The K1.
K1.
Or 8, which one?
7th equation or
The 8 of.
8th one?
Yeah.
Okay, basically now it is come over here, right? Basically this two is trying to push and this is trying to come again. So after that you have mass, after that only this one. So this is good enough to say on this state component. I mean that's why it's a direct component on it. Yes.
So then how does 7 work? So, like, why isn't it the same concept for 7?
Okay, basically 7th is external force when I apply. So this is going to be stretch out. Yes, this component is there. This is trying to resist the mass, is trying to think. This is another component. And it is going to be, because you see, there's another thing coming to it. That's why these two components include. That's mostly the first layer of the system which is directly connected, then we add it. Otherwise, then we can omit all these things. So this is trying to be equilibrium. In other terms, whenever there is another mass coming, we can able to stop over there because mass will dampen everything. Okay, so you can have a control. Whenever the mass is there, we can draw a line. I think you can draw an imaginary line over here. Then you can cut off whatever component M1 and M2.
So, equal, right? M2 and K3 is like the shaft 2 of the previous question, right?
Yes, you can say that. But just shaft 2 is, I mean, over that part is very clear in a way like these two different shaft components. Whether the linear, all in one row, whether it's horizontally mounted or vertically mounted, it's the same thing. Yeah, you're right. You can say as long as two things will be different. Yes? Any questions? Okay, basically now, can you do a block diagram of this, which is even bigger than the chart? So, very simple to say, you start from input and output, then put whatever things middle. That's all. Once you incorporate the equation in the block, strike it, then you know what you covered so far on the block. You need to build step by step. Is there any question at this moment? 8 equations. So, okay, very simple for all these topics you want to write. Make yourself clear on the first 6 equations. 6 equations, you need to refer your formula sheet. Just write down from the formula sheet to the 6. Each carries at least 1 mark. Okay, so it is the base. If this equation is wrong, means entire equation is wrong. Yeah, because it's the first one, right?
Yeah.
Yes. You'll get marks, definitely. That's the hardest part for marking this subject. Even though it's wrong, I need to say 0.5, 0.5. You need to have a calculator to cut everything, then get a total marks on it. Okay, but why is 6 equations important? Because if this equation is wrong, everything is going to be wrong. Okay, because that's the first combination. Okay, but it is simple. It just only these 3. Okay, it's not really matters. One thing to say, one is when you talk about mass, you have d square. So very clearly keep it. When you say mass is d square, damper is d. So I think right over here. So damper is 1d. You need to put it. So I think it's over here. So mass is d square, whereas the damper is 1d. Okay, so velocity. Whereas the spring is very simple, x1 minus x2. So one is d square, one is d, one is normal. Okay, so that's a 3 component. No matter how many components combined on the system, which is basically all these 3 components. Okay. Okay, so let's do it. Block diagram. Okay, so help me go step by step. Okay, so we already know it. What's your input?
U.
U. U right here. Output?
X2.
Okay. So we want to start. Okay, start from simple one. Okay. Anything relevant to U, then you can consider that because it's U, right? So all the 8 equation we need to put it over here. Okay, so very simple. Where is u over here? Okay, I can write it here also. Yeah, 7, 8 here. So where is u? Yes, u only here. 7th equation. The rest of the equation I don't see anything u. Okay, because my input is u, so I need to start from there. Okay, and what is the u on the 7th equation? All the forces, including all the components. Okay, add together. Okay, then we'll get it like u. Yes. Maybe I'll start with the simple one, which is say is 5. Okay, because put here. See the component. I mean now all the 4. Let me mark it first. K1, M1, K2, then B. Yep. Okay, equation 1 to 4. Okay, which is relevant to you. Okay, so now here is a x1, x1. Here is x1 minus x2. Okay, so maybe I'll just take these two first. Okay, so x1 and it just only what you can say k1. Okay, and here is the md squared x1. So these two components, then I can make it first. So in other terms, maybe for simpler understanding, I can say this way. All the 4, maybe I put it first. B, K1, K2, right? It is equivalent, right? So basically once u, right? U is nothing but all this thing will come over here. Okay? So that's where the combined things will be here. Okay. So first I will take mass and so-called the damper. Okay, first equation 1 and equation 1 and 2 because just x1. Okay, so I will take x1 to do the things. So somewhere then it is x1. Can I say that? So this x1 is there. So u x1 and the last one is x2. Okay, so I can make it one more line on it. So if we say x1, what is the x1 over here? First formula, maybe first equation is right for understanding. B squared. Oh, I written over there differently. Okay. So let me get it. K1, yeah, K1 x1. So here third equation. Doesn't matter. Just write down that. Then we have temper m1, right? M1 is nothing but m1 b square x1. Okay. So I'm trying to convert these two equation 1 and 2. So in terms of x1, because x1 is there, so in terms of x1 is nothing but fk1 divided by k1. Can I write this way? Basically the first equation, I try to keep the x1, then make the equation accordingly. Over here again same thing, x1 is nothing but f of n m1 d square. Can I write this way? So that is easier to get over to the equation. Okay, so first thing, of course, this is a summation. I will get a block. Maybe I'll try to put first one. So, which is the first force, F by K1. Maybe I just put K1 first. So once I have something, so it will be multiplied, we'll get this. So this part I can say K1. So I mean like once I get a U, K1 means K1 times this, you will get this one, which is nothing but X1. Can I say that this one? So I try to get as an input and multiply with this or whatever the rest over, then when multiply we'll get it over here as an X1, which is simply to say, so Fk1 multiply this, you will get this. So nothing but our formula. Are we good on that? So force K1 multiply with this gain then you get something like that. That's nothing but the x1. So which is derived from your equation 1. Okay. Likewise, you can do the same thing. I will get the force. Maybe I don't put this one first. There is another gain. Okay, so which is going to connect, and that is going to be x1. So I need to get something like this. Okay, so what we can say? 1 by m1 d square, which is nothing but force of m1. Can I write this way? Force of m1 multiplied this, which is equivalent to the x1. So you need to build from equation 1 and 2 already. Try to equate like x1 and x1 over here. When you come over, you will get the x1. Are we good? We have a question. Equation 1 and 2 converted into a block diagram. So maybe I will write the respective terms over here so that it will be easier to follow. M1 b square. Okay, so this is also called as x1. Okay. This one I write on the side because the x2 still remains. I try to make it over here 1 by 1 so that we will be referring. Because we need to connect more things, so let us connect this.
Hi.
Yes,
Do
question.
we need to write the equation in the final answer?
You mean this one?
The one above.
Or this is for your reference only?
We don't have to write it.
You don't need to write. Basically, I try to see like once you multiply this, you will get that answer. That answer is nothing but actual equation. Okay. But when you want to write, whatever I make circle, don't write it. That's circle one for your reference only. You can write because next time when you read, at least you know why it is there. Test no need test. For your assignment, exam no need. For your reference, yes. But still you can write because sometimes so many equations in there we surely miss out actually. I think it's a good practice to write, but you try to make it some different symbol, like circle symbol. The next thing once coming, you're going to follow it actually. Whatever the next thing you follow it is only whatever on the box only. So box only we need to reduce it actually. Yeah, just take note on it first. Then if you have any question, let me know. Then we go step by step. Now I'm going to proceed is equation 3 and 4 as per the board. Over here is 4 and 6. Okay. Yeah, 4 and 6 as in the board. Actually over there is 3 and 4. I'm going to connect it because we have x2, right? So x1 is there. And that is nothing but I'm trying to equate our 7th equation. Force of A 1 by d square, okay. Okay, so questions so far, block diagram. Okay, so next, okay, whenever you're done, you try to take it so that we know what we completed. And this is partially completed from the 7th, yes. Now we have x1 minus x2 over here. And we don't worry about the constant over there. We want to connect because x2 is there, or your symbol is already there, x1 also there. So I'm trying to equate this. We have me to write that. Now it's K2, right? Sorry, not K2. Yeah, K2 and B. Okay. So K2, x2 minus x1, or x1 minus x2. Then B is D x1 minus x2. Right? This is your third equation and fourth equation. Try to change the equation in a way like I want to get it, maybe I have to put it this way. So I can say x1 minus x2, the K2 will be going down. Okay, so it means like your force of K2 divided by K2. So that's how I'm rearranging with x1 minus x2, which is rest of the terms will be the other side. Then the same thing for the fourth one, B equal to BD x1 minus x2. So if you write x1 minus x2 is nothing but force of B divided by BD. So we could just rearranging the equation 3 and 4 in terms of x1 minus x2. Okay, so we have x2 and we have x1. Okay, so both we have it. We try to park this one between this and this. Okay, but of course I need to get x2 because we are very simple. I want to get it. I will write over here x1 minus x2. I get a pipeline over here. How to get x1 minus x2?
Feedback from x2.
Feedback. Okay, I need to get a point, then I need to get over here. Okay, so I need to put minus. So it means like I take x2 and wherever it needed you can put x2 so that you won't get confused. So and this component, what we already have x1 over here, it means like x1 is coming, x2 is coming. When you have minus of this, yeah, x1 and x2 will be getting over here. Questions on this? I take x2 and here x1 is coming, minus of this will get over here. We do? How we can get it, the relevant terms connected and make the block. Then you can put these terms accordingly. Now you got x1 and x2. Yes, you can make your two blocks over this. Questions? Okay, good. Why we get the feedback? Because we need to find x1 minus x2 on the system. Then we can able to make it in a way like fk and so called bd. So that's another two equation will be there. Yeah, so maybe I'll put it this. Are we good? So now you get like here. So this pipeline will get it here. Then I can make one block, or I can take another block also here. Okay. So one block is representing this, which is nothing but force of K. Then another one is this. So you can able to write that. Then we can able to complete to get everything. Don't connect first. So just make it here. So once you multiply, if I want to get it, force of K is 1 by K2 and this is BD. Okay, so both is when we multiply, then we can get it. Yeah, so you will get it one more block. That's where you can have this. So then you can connect everything over to the other side.
So what happened with the FK2 and
FK2 and this. So obviously, yeah, you can say together, or you can have another thing. Now I just put it directly FK2. I think yeah, better put together in the sense. Then you know you have one more block. Same thing you take and put over here, and same thing you put here. So now with that two blocks, you will get over here one more point. So as long as we now have equation 3 and 4. Question, yes?
Can you do the same thing?
Yes, you can also do the same thing. To make it simple,
Okay.
yeah, you can do the same way. So it's much more easier to understand, to connect also. Okay, so now I can do this, but temporarily. Okay, now what is your, okay, 3 and 4 is fully completed, right? Or you have equation on 3 and 4. Okay, so now you are you able to relate any other equation to complete? Okay, equation 3 and equation 4 is completed. Okay, so you mean like all the forces, you have the box, right? So which is equivalent to the U. Okay, so basically all is added together. So this one is nothing but these two. I can take a point. Maybe you can go top or bottom, doesn't matter. So if you take this point, what will get it? It's nothing but your x1, x2, right? You can have this force, and these two forces will get it already. So I'll take a point and go over here. Whenever multiple points is there, you can put summation. Okay, so what do you get here? I mean, maybe anyone can tell what you will get here. Fk and Fb will get it, right? If I take the point from here, so it is nothing but, maybe I'll put it here first. Fk okay, maybe there's one thing I can rearrange, so that will be much more easier. If you have x1 minus x2. So we have x1 and x2, when I multiply with k2, what we will get it here is k2 x1 minus x2. And here it means equivalent to k2. Okay, sorry, rearrange this in another way. It's much more easier to do this. Okay, so if I say k2, and what we get here is x2 will get it, x1 will get it, is nothing but x1 minus x2 on this point. Then multiply with k2, what we'll get over here is fk2. So I think in that sense, you don't need to rearrange this. We can follow the same pattern to the other side. Yeah, so because I was thinking the other way to do it, but your block diagram is getting more complicated. Okay, so I try to make it simple. Now we have this one. Okay, what over here is x1 minus x2, right? Because we take x2, and here what is coming is x1. Summation, what got x1 minus x2. Yes, you got this one. And when I multiply with this, what do you get? K2. So I put it K2 block. When I multiply this, you will get it like K2 x1 minus x2. Can I say that? Because x1 minus x2 multiplied with k2 will get this, which is nothing but fk2. Then I can go with the same simple concept. There are x1, x2, which multiplied by bd. So we'll get equation which is nothing but fb. Are we good? So it may even much more simpler. That is going to be more complicated when you do it that way. Okay, I try to make it simple, and now we can take a point once over here. Then I can take a point from here to go. So what we get here is FK and FB. So that's a takeoff point, FB plus FK2. Can I write this way? Because there's one force is coming, then second force is coming, and I take out the point from here all the way to the front. Okay? Then we can do it in the sense. I can also do the other way. I don't need to go first equation this way. So let me think. Okay, so you have x1. Okay, so multiply with k. Okay, so we get fk. Yeah. Yeah, you can do the other way also. Yeah. So first thing, is there any question on this part? This is coming all the way here means you get your FB plus FK2. Yes.
As in equation.
Because your seventh equation is all the forces. Maybe I can say, yeah. You have M1, K1, K2, FB. So all must be put together. That is what you will be there. So, but you need to connect that to take, then we can connect accordingly. So I take out the point, and of course this is positive, okay? Because these two forces you can take and do it. You can also connect as one line, okay? It doesn't matter. Can I do this way? But of course, yeah, because anyway this is K2, this is FP, both is can take this way. In sub 2 double line, you can make it in one line itself, but the things will be always the same thing. Are we good on it? Even you can take separately or you can join together, then we can able to get all the bar, and so that it will connect to the U. Okay? Yeah, so when you draw, you try to erase it and try to make it simple, simplify. And so far, yes, this is x2 coming in, so that I have x1. Yeah, I try to make it simple this way. Yeah, this one I cannot change because x1 is there. So I need to get x1 as output. Yes, just the one remains as it. Okay, so now if you put this one, they will like all join together. You want to write, yes, we can write over here. This one is B. It's nothing but BD x1 minus x2. And this one is K2 is nothing but K2 x1 minus x2. Okay, so whenever you make the block diagram, you try to multiply and see whether what is the result coming. Then match that equation, see whether your equation is matching. Now that's the other way to cross verify whether you are in the right direction or anything mistake over there. Okay, so this is x1, this is x2. This particular arrow will be like x1, x2. Then I take over here, multiply with this. So K2, this one will get this equation, nothing but our third equation. So then I can get the same thing over here, multiply with this, we get this equation, which is nothing but our fourth equation. So likewise, we can have every single equations, then ensure whether we get everything. Okay. So yes, this is so far 4 equation complete, and seventh equation completed. So we have another 2 more equations. Yes, now the board is getting crowded. Okay, so how to connect? Okay, still have x2. It's okay. What is the 5th equation, which is relevant to mass and x2? I think it's simple. don't need to connect anymore on the back side, is over here. Then you can relate it. Okay, so better write it out fourth one, then no need to really do anything. Any question at this moment? So try to make a block on here, this portion where the x2 is coming. So you can relate first, better write it out. So 7th equation done, we have 5th equation and 6th equation. Okay, force of mass 2 and we have K3. Okay. So we have M2 d square x2, then we have K3 x2. Okay, we have already x2. So whatever things coming in, then we can put it on here. So how do we make it?
Equation
Equation 6, okay.
8.
Or 8, okay, so what is 8? Oh, that's another part that need to be added. Okay, now then you have 8. 8 is basically equating, right? K2B, K2B already there, yes. And yes, trying to match with the other two forces, M2 and K3. So that is the next part of it. It's nothing but opposite, so you need to take minus of it. Okay, so any idea?
Parallel.
Same as the first one.
Sorry?
Same as the x1.
Same as the x1. Yeah.
F over k1.
F over Q1. This one.
Like those two boxes, but same equal x2.
Actually, you can also do that. You can make the other way also to make simplify it. You can also do that. Okay, so now maybe just go with the last part of it, which is nothing but your equation 5 and 6. We have 2 more boxes we need to make it. Can we make it here? Yes, okay. And yeah, I need to rearrange the equation. Okay, so x2 is nothing but m2, then we have m2 d square, right? So x2, the rest of the things will be here. So we need to make one more box over here, which is nothing but whatever we are getting. And okay, so I try to make one box here. So here is x2. Whereas when you input is over here. So you can also do the same thing, m2 divided by m2 d square. Okay, so then you try to make it one more equation and complete the things. I don't have a big space. Okay, maybe I try to make it over here. Whatever here, then you can join. Okay, so that's another last box we can make it. Then let me check. We have everything is connected. What is K3? K3. Oh, 6. K3, X3. So yes, 7th is completed and K3, X2. Yeah, there is no 3. So X2 is nothing but K3 divided by K3. So that's another box which is over here. So overall, yes, all the parts is joined. Then we can able to complete it. And then you can put as a feedback also, similar way. But if you have multiple things is there, better make summation point. Any summation, take off point, summation.
Landscape.
Take off. Okay. Yeah, you need to do this way because we need to take and come over here, take off point. Then three things come over. Okay. So when we say 1 point take is okay, you just put one takeoff point. But if you say multiple points, I mean more than 3 is connecting, then you put summing point. Okay, so slowly convert after joining, then we can say summing or takeoff. Okay, so that's how we can convert all the equations to complete everything. Let me recheck. Is there anything to be added? So we got this. Okay, yeah. Yes, we have. Actually, in fact, if you want, then we can also simply, okay, when you write, you can write this way, or we can make one big box. We can able to say add one box. Let's say in this case, you can write this way. So yes, of course, direct conversion of individual equations supposed to be like that, but the next part, of course, this is parallel, right? So it can be add together like this. So of course, this is you can do a reduction technique, then you can do it. No need to do on the first step itself. I think better I tell it. Avoid confusion. So basically, all the equation will make individual box. Then we will be make sure all the equation is completed over this. KB. Yes. So everything is connected. So X2 is there. So X2 is connected. Okay. So everything is done over here, but we can verify and see. Over here, very simple, 8th equation. Where is the 8th equation now?
At the
Because
summation
now
point.
7 equation completed. Yes, 8th equation.
Is at the summation point.
Summation point, yes, this point. Because if you say so this until this part is your, you can draw an imaginary line. Okay? So if you look on this part, it's nothing but K and B, you can able to see here. Okay? K and B. And this is reflecting our mass 2 as well as our spring constant. So it is two different things you can able to see from here. Okay? So it's nothing but it automatically enrolled in your 8th equation over here. Okay? So all is put in a block, then you try to simplify it and then connect it. So then that's the first step, converting your equation into a block actually. Okay, so based on the question, some may be very tedious, some may be very simple. But even when I write also, the first time when I write, you can have other ideas. But you delete it and make it more simplified version. Okay. In simple terms, I can say as we started x2, x1, then u. Right. From there, you can fill up accordingly. Whether it's going to be feedback or it can be direct joining. Okay, so that you can do it. It's nothing but whether it is going to be arrow direction, whether it's negative or it's just a positive side. Because if you see, look, this one, I take directly and do it actually. So the point when I take x2 to get over here is going to be feedback. Okay, so try to connect, I try to solve all the equation into a block actually. Then those what I have written in circle form, just for understanding only. It's not really required. Maybe if you want to write, you can write on other locations.
So just check. The summing point before x2 should be a takeoff point, right?
Yeah, this time I put it like a, yeah, it's kind of takeoff point. Cannot be. You have to separate out it because this is, I need to take out separately. Yes, correct. And this is going to be your joining point. Yeah, you can say like two different summing points. Because once it's coming, you get x2 already, and yeah, from the x2 you can take over here. Yeah, you can do that. You can have summing or directly joining, then you can able to reduction accordingly. Yeah, you can make it this is as a summing point because two equation is there. Whether summing or take out, you can take put it accordingly. Yeah. Okay, so maybe I'll stop over here. The reduction techniques, you can do it until to your final step of it. Maybe I will put the answer. This is the answer.
要可以啊，怎么样？
Okay. Yeah, that's our answer, which is nothing but your x2, right? x2 versus u. Okay. So that is your final answer. We have a multiple terms over here, but it's solved using equation method. You can use the same block method until to get your final transfer function over here. Okay, wherever you see s, right, you can put it d. Okay, so it's d power 4, d cube, d squared, and d. Okay, so because it's written in the Laplace transform method. Okay, so that's our time constant. The next one is obviously this is already written. It's in the liquid level input and output, Q in, Q out, and that is our sixth equation. Maybe you can take your time to look on this sixth equation, which converted this way from start with head and to the head 2, which is covers all the six equations, and you can make a block diagram, which is you can take a reference one by one all the six equations, then you can connect accordingly. Okay, so this one I can leave it for your reference for the fluid system. Okay, so this is nothing but summation, so you can have a cross symbol on it. Okay, so the last one, of course, a bit more easier chapter. Okay, come to this, as long as the block diagram is completed, now we have control system response. As we know, our control system output versus input, you get the desired value. Okay, so when you talk about any control system, there will be three different methods. One is step input, ramp input, sine input. So it means like the signal is rising suddenly, or it is periodically linearly raising, or it have a sine waveform. Okay, it is normally used to determine. And this chapter is more towards formula driven substitution calculation. So this is the first order system, which is nothing but our KTD plus 1. If you say first order system, something like, without this square or anything, only D. The formula is already derived, so we don't need to really worry about how the formula is come over. It's in the formula sheet as well. As long as the first order system, then the question says step input, then you can use this formula. Okay, which is nothing but our gain constant and time constant. Okay, so there will be some example which is mere substitution only as per the formula. Okay, so first example, that's your first order system, which is S or D, which is say like this is first order system. So you can able to calculate which is based on whether it's step input or ramp input or sine input. So how do you get the values over here? Of course, when you have this is step input is represented by the theta, which is h. Okay, gain we already know, which is from the control function. Here supposed to be 1. Okay, so it's nothing but 4 divided by 5 and 3 divided by 5. Okay, then we use our formula for step input first order. Then substitute all the numbers. Then we can able to get this value. Okay, maybe just quickly work out this. Then we'll continue this question. Okay, so over here,
我是要开好的。
HA1 minus exponential E divided by C H is
What's your
6
jacket?
multiplied by 4 by 5. 1 minus T is mine and 5 by 3 probably. Okay, so you can multiply, you can, let's say 24 divided by 5, kind of 4.4 means 8, yeah. 1 minus exponential 5 by 3 is 1.67, yes. So that's the answer for this step input. Plotting will come later because it just obtains the value what we get this answer. Plot we will do using method. Okay, so plotting the systems we are not going to do now. Maybe after your break, after your midterm, then we'll do it. Even the midterm doesn't going to ask about plotting the graphs. Questions on this? Yes.
This duration
Come again, please.
this like this step input or this calculation is it part of your midterm?
In the formula sheet, yes.
The midterm next year.
Oh, midterm, yes. Because it's topic 3. So, until what we are exploring here, we'll be having there's one question based on this. Okay, so usually the last question based on either sine, ramp, or step input. So that'll be last question on based on this formula. Of course, the formula is already in your formula sheet. Okay, so you can take refer, and the question is typically like this. Okay, so we need to find it out what is the response on this. The next one, of course, over here they've given a system and they give A, B values and substitute all the A, B values. Finally, you need to get it with it's a step input. So step input formula we need to substitute to get the value on it. Okay, so maybe example 2 I will make it here because it is not written fully. I have the answer for it. Okay, don't have. Okay, let's do it. Okay, so over here A is 100, B is 300, capital A is 650, 2600, whereas H is 12. Okay, so that's the number given for your second question. This is your first one. Okay, so basically now they given a transfer function over here. I just directly substitute the number. C by A, 300 by 100, and 1 plus, so 100 plus 300 divided by 100. Okay, so multiply by 650 divided by 2600 D. Okay, so that's a mere substitution. What we can see here, D by A, which is 300 by 100, and 1 plus A by B divided by A, and the capital letter A and spring constant K. So yes, all these numbers were substituted. Maybe I can put it this way: 3, 1 plus this whole jump. So it's basically 400.
Sorry, where you get the H? The 12.
Which one B?
H. on top.
H is over here. Step input.
Oh, step.
This one. Okay, any other questions? Okay, so over here 4, maybe calculate. 30.
D.
Or D is there, yes.
It's just 1 D. 400 over 100 or then
4,
1 quarter. 650.
yeah, that's the number. Let me, I don't know whether I don't have it. Let me see what thing. So 4 times 650 divided by 2600. I think it's 1, right? H. H is on here. The question given 12. Step input 12. That's the H. So it's based on the question, you are either step input or sign input. So this is we call as H. So rest of the numbers, yes, given like here. A, B, capital letter A, K. Any other questions? So it means like here, this is final 3, 1 plus D. Okay, so you can have all the values. What is K value now for this? K, 3. Okay, T, 1. Okay, so you can substitute the numbers onto the formula. Then you can see like H is 12, K is 3, 1 minus time constant is also 1. So it's basically you can say 36, 1 minus T. Okay, so we good. It's just like that's your final answer for the second one. So you substitute H value, K value, and the time constant. So everything we substitute, we get the second example. So all the data is from the question. So we good? On this.
So for the equation, what do you get
H and K.
this side?
Oh, this one. This is the last one. The H and K.
Right.
Yes. So this is the first one. Obviously, K is the gain constant, 4 divided by 5. So that is your gain constant. Okay, this is the first one. This is the second one. So let me draw things. Okay, so this is the second one. Oh, sorry, what to take? This is the second one, what we are done. Just a mere substitution to calculate, to find what is the step input response. Response of the system. Then ramp input, still the same first order systems. Okay, the formula is expanding. Okay, so which is not like a step input. We have like two more terms. Okay, so this one, obviously maybe I'll write on the other side, so you can able to calculate accordingly. Okay, so over here, what is the K value? Better write on
4 over 5.
4 over 5. Okay, 0.8. Okay, so 4 over, I think is 0.8. What is the T? 3 over 5. So 0.6. 36 degrees. Yeah. Then H value from the ramp input over here. H 1. Because there is no number given, right? If number not given is 1. Because 1 multiplied by T is T. Right? So if you refer our board one. So over here is given, okay, so they given like this, or if they not given, you can refer this as a 1. Okay, the H value is 1. Okay, so mere substitution all the values, which is, yeah, I think it's already written here. Okay, H is 1, K 0.8, time is given. So you just substitute 0.8, H is 1, then T minus 0.6 plus multiply these two will get it H and 0.8, and time is 0.6, that become 0.548, and T is, you can put 0.6, no need to write this way. So it's a mere writing of the equation. If you want to write, I can write here. So this is third one. One multiplied by 0.8 e minus 0.6, then plus 1 multiplied by 0.8 times 0.6 exponential minus t divided by 0.6. Simple to write, 0.8 t minus 0.6. This is 0.48 exponential 1 divided by 0.6. Then you can count the number of it. Yeah, 1.67. 1 divided by 0.6 will get like a minus 1.67 t. So that is your ramp input formula, what we can say the response of the system. So that's your final answer after substitution. Okay, so sine input. Okay, so when you talk about sine input, the terms which will have one more extra, which is actually h is nothing but 2, whereas omega will be near to the sine. Okay, so this is your h value and this is your omega value. Okay, so based on the equation given, then you can able to get the number, then substitute onto the equation. This is saying that what is kind of type of input, just sinusoidal or sine input, then we can get h and omega is near to the type. Then we can follow the sine input formula to get the response. Okay, so this is the sine one, of course it will go expanded. Okay, so substitute all the equations values, then we can get it. Okay, so the next things, we better write down this one. So once you get the one thing on sine is basically we need to make a differentiation after substituting the equation. Except the sign, then the other two is just substitute, you get the answer already. But over here, we have all the data and the formula you can substitute, the formula is over here. Substitute all the terms, then make a differentiation to equate to 0 to find exactly what is the time constant will be there. Okay, so first thing, I don't write this entire thing. First I will put it h, omega, k and t. All the values is get from our question. Okay, so come over here. Okay, k is 0.8 and this 2. Okay, better write that one. So yes, 0.2 and 0.8 is 1.6, right? So it's 1.6. Okay, divided by, okay, I think there's a lot of things. Okay, better write 0.8 times 2 divided by square root of 1 plus omega t is omega is 0.1 multiplied by 0.6 square sine omega is 0.1 multiplied by t minus 5 plus 0.8 times 2 times 0.1 times 0.6. 1 plus 0.1, t is 0.6, square exponential minus time. Okay, so I just substitute all the values, then we can able to compute this, then we can able to get until here. Okay, so it's just nothing but square root, square, then square root it, then 1 by square, you can get everything, it will be like here. Okay, any questions on this? It's just a mathematical equation calculation, yes.
How do you get 2 for H again?
H is from previous steps. Okay,
So just get the first number.
this is the first number where it's a H,
Okay.
and which is with respect to t, that's called omega,
Oh, okay.
which is for sinusoidal, sine wave. Okay, sine wave, which is to say so this is our H and this is your omega. Okay, so maybe you can take your time to solve this, and we'll get the equation something like this. So you'll get like all this thing. But if you look on here, we don't have a complete numerical value of here. Okay, so why it is not? Because there is one more term, is a phase phi is there. To crack down, obviously you need to equate the entire equation by 0. Okay, so in a way, like wherever time is there, you can substitute 0. That's the next step. Because we look on this entire equation, there is two terms. One is t, another one is phi. To get the phi value, so you need to equate the equation with a 0, which is initial condition. Equal to 0, and time also equal to 0. When you put these two factors into the equation, then we can able to solve it, and then we can able to find it the value. Let's say now the theta you put 0 and the time also 0. Okay, then this one remains and the time is 0. Exponential of anything 0 is
1.
1. So this term is going to be 1. Yeah, that's what you can see over here. And yeah, this is 0, 1.597 sine of 0. This is going to be entirely 0, that is become minus pi will be 0. So this term is going to be 0 because the time is 0 8. So once you put the 0, then rearrange until you get what is the phase angle. Then substitute this into the main equation. So over here, you just substitute this area. That's all. So one more step with the initial condition and time is 0 to calculate what is the phase. This only applies for the sinusoidal waves or sine waves. So apart from other things, you just substitute, you get the answer. When you say sine means you need to make initial condition, then get a phase, then put the value into the final equation. So are we good? Or yeah, any question? I just move. Okay. Okay. So anyway, I will share this slide so that you can recheck the number after calculating. Okay, come to the second order system. Okay, second order obviously is very obvious to say whether it's d square or d, and we can do it. But the formula is slightly changing because the more terms will be there. It is called complementary solution and particular solution. And it's another term to say transit or steady state. Okay. The formula is still expanding, but it's based on two things. Two things together, then only can make the complete solution for it. For second order is expanding, but still the same thing, sine, step, ramp and sine. The formula is different on it. but even complementary functions. Okay, maybe this is also available in your formula sheet. You need to memorize, so we just need to use it accordingly. Okay, so second order is probably your similar question will be on the midterm. Okay, not the first order, usually second order will get it. Okay, second order, obviously you see kind of d square, it reflects that it's second order. Okay, so it's still the same thing, three types of system. We have first one is step input, okay, and when the value is given, that value is nothing but h. Okay, so let me put it. The formula is not shown here. Okay. Okay, the formula for the step input is k and h. It's nothing but the gain constant h. So come to the question where you can say k and okay, so over here k and h. So gain constant is 0.016 and h is 20. That is your first particular solution. That's the first step. Alright, based on the step input. Any question on this? Okay, so there's one other thing to highlight on here, because this is the first time you are seeing your second order. We have multiple time constants will be there. Okay, so over here, the numerator, what we can see is your gain constant, and followed by time constant 1 and 2. Okay, so that is where we say second order system will be there. Okay, so wherever d is there, that is your respective time constant. Okay, the h value is given is 20, whereas k is on the numerator. Whereas time constant 0.17 and 0.0277, which is relevant to that. So from the question, you can record the values. What is k value? What is t1, t2, h value? Okay. Anything? Any question at this moment? So once we have all the numbers, then we use the formula to calculate the particular solution and complementary solution. Particular solution is straightforward, but the complementary solution, we will put it this way. First, we need to calculate what is d1, d2. Okay, so that is the formula what is given over here. Then we substitute to get all the answers. It is nothing but time 2, time 1. So all the numbers when you substitute, you will get the relevant answer. So when you say it's a complementary solution, so what is complementary? Obviously, when the square root, whatever the number will get in minus, let's say minus 5. So if this number, what we get is in minus within the square root, then it is called as I. Okay, complementary solution, which just reflects the balance. So when you say like 35 for reference, so it is 5 when you square root, but this is a minus, we put I. Okay, I means it is the square root values in minus. Okay, so maybe just take a look and do the calculation, and whenever there is a complementary solution is like this, then the condition will goes to over here. Maybe I'll show the formula sheet. Let me get that. Okay, so first we do a d1, d2, and whatever the number getting in, there is a full condition over here. So whether it's a complex path or real equal roots or negative roots or imaginary. So when you say complex is something like minus on the square root, you get I means it's complex. Then we need to use this formula to use it to calculate. Okay, but for complementary solution, first step we need to do this one. Then based on that, how the values is getting, then we can choose either one of this formula. Okay, so for this case now we are in the complex square, so it is nothing but that formula we are using, and we are need to substitute all the values, which is nothing but we just see the details on the next step, which is nothing but how derive from this step to this. Basically now last step we already know our particular solution is 0.32. So your particular solution 0.32, and this part is nothing but this. So we'll return everything. So here there is unknown will be there, which is nothing but phi c complementary as well as b. Two unknown is there on this second order system. So like your first order system, we need to equate to 0, then we need to calculate. How we need to do it? Basically, this is your final answer. Of course, I could refer next slide. So first I will turn down the entire thing. The first step we need to differentiate. So differentiate this entire equation, then you can get the equation, then you can substitute accordingly. So differentiation, but not so complex differentiation over here. Okay, so very simple to make it. First, when you say differentiate this entire equation, is a constant, it's just a number. When number differentiate, it becomes 0. Okay. Then when you differentiate, because there is two terms will be there. One is with the t over here, is again another t is over here. So two different components. So first, how to do it? Basically, we can keep it be. I mean, we differentiate this exponential. So when you say exponential differentiate, the top value will be coming at the front. Okay. So hope you recall your basic differentiation things. So make it simple. So what will be the differentiation of this is nothing but 3 of x. So whatever the number relevant to the x terms, get over here. Okay, if it's a plus, you can put plus. If it's a minus, even p or x doesn't matter. So it's a minus 5 e power minus 5x. Okay, so that is a basic differentiation thing. You can recollect that. Okay, so basically now come back to this is minus 3.07 on the top. So that's why we return over here. D, E, everything remains, and this entire term will be following in. Okay. Then because it's the two the multiplication factors, so that's the first thing. And second, you need to write the same thing over here, B, E. Then sign become when you differentiate become cos. Okay, sign differentiation is cos. So sign become cos, and this term with respect to t values, whatever number here, you need to write it out. So this is how this entire equation, when you differentiate, these terms will be there. Okay, so questions over here.
Will this be out in the exam?
Come again?
Will this be out in the exam?
Differentiation is needed, otherwise we cannot find the value of b and phi actually. But I mean, there is no differentiation formula given, but it's general. But it is one of the defined question in our midterm. I think it will show you one question will be there. But it's just a matter of whether it's a sign or step or ramp. Either one will get a minute. Okay. Maybe just go through this particular questions because it's just one differentiation step will be there, nothing else. Okay, so then you need to rewrite. So that's what we done over here, and that final answer will be over here. Then it's not completed over there. It's nothing but now we differentiated. Then with respect to 0, then you can try to make it time equal to 0 on that equation. Everything is simplified. Then you can get the final answer. Okay. So in simple terms, I put it. Now what we get over here, okay, make t equal to 0, time equal to 0, put 0, everything, so now we come over here. So if this is when it is 0 means it will be 1, okay, and here is 0 means still you get sine phi c, and here is 1 cos phi c, so that is everywhere what you get it, you try to make it initial condition 0 and you can have two equation on it. When you solve it, you can get b value and phi value. So that you substitute to the particular function. Okay, so it's kind of differentiation and finding out using algebra. Okay, so actually it's running out, so I just leave it there. But similar examples is there. Even you can follow this example. I think is you can follow the same pattern for your midterm. Okay. Yes, second order system, same ramp input is given and the time is also given. If it is not given, then you can put zeros. Yeah, H, K, T1, T2. Then we can get your particular solution based on the formula. Then we can have our roots, which is again the similar pattern formulas. Then we can substitute and we have initial condition to equate and make the b as well as the phi. That you get your final answer of it. Okay, similar numerical solution, but the detailed one I written how it derived over here. Okay. So these are all the detailed steps, how to equate it, how to get the b values. Seventh one, which is something similar. Let me see whether anything. All will get the complex one. So as long as you get I means same, d5 will be coming out actually. So the same information. Okay, so this is about theory, but we'll go through later because it's like a settling time, rising time, and everything. It's nothing but the signal once it's come in, instead of normal, how much it shoot up, all gets stabilized after some time. Okay, so that is the formula for it to calculate, which is also in the formula sheet. For second order, you can see the formulas over here, which might be not going to ask on midterm, but for your reference, you can keep it for future final exam. And this is just to calculate nearly all the times. Okay, so this is not really needed at this moment. Okay, but anyway, I had all the values over here to do it actually. Okay, so yeah, so any other questions at this moment? Of course, the last part is a bit rush up, but I strongly recommend to go through either one of the second order systems, either 6 or you can go for 7. Question 6 and question 7 you can go through it. This is your 1 week time. Then we can able to make it. Okay. Otherwise, I need to record a video. Then I'll try to send a video. Say like how the detailed steps are there. Then go along with the notes. Okay. So maybe I'll work out the question 6 and 7 and make a separate video. Then I'll WhatsApp you. Then go through with the notes and the videos, then you know how to work out. Then because that is going to be a good reference for your midterm, just like next week. Okay. Yeah. Any other question apart from that? Okay. So carry on. But wait, we have a minute. Yeah, attendance. Because this is classified as absent here, yes, third one, okay. Any others?